Greetings, my beloved scholars. I'm Mr. Okafor, PC, online physics teacher. Our topic of discussion today is equations of motion. Equations of motion. If you must do well in physics standard exams, external exams, you must be good in physics theories, physics calculations, and physics practicals. For you to make a sound physicist or sound physics scholar, you must be good in physics theory or theories, measurements or calculations, and practicals. So today we'll be going into one of the measurements or calculations in physics, equations of motion. Equations of motion. It applies in every physics exam. There are 4 equations of motion. For you to calculate how motion occurs in the natural setting, you need these 4 equations. The first one says V is equal to U plus AT. Then the second one is T on V. V square equals U square plus 2AX. Then third one, X is equal to UT plus half AT square. And the fourth one, X is equal to U plus V over 2. That's average speed. U plus V over 2 times time. These are 4 equations of motion. 4 equations of motion. Every physics student must know these equations. You must have them at your fingertips in order to perform well in mechanics, measurements in mechanics. Okay, I don't support cramming of formulas. It won't do you well. As a sound physics scholar, you must know how to derive your equations or your formulas. So today I'll show you how to derive those equations on the board. You don't need to cram them. It's not necessary. Okay, but before then, let me tell you what each symbol stands for there. What each parameter stands for. Okay, starting with V and U. V is final speed or velocity, final speed or velocity. Then U. U is initial speed or velocity. The speed you start with is the initial speed, and the speed you end with is the final speed. Most times our initial speed is 0. Most times. But some other times it's not 0. So anytime we use the continuous verb ing in motion, ing, a car moving, a bicycle moving, a car driving, is also initial speed. Because driving means that with time it will do what? It will change or end. So ing is also standing for initial. If a car is moving at speed of 10 meters per second, then initial speed is 10 meters per second. Because anything moving with time will do what? Will stop moving or will increase the speed. So take note of that. Most times our initial speed is 0, while some other times we use the continuous verb ing to indicate initial speed. Ing, initial speed. Then both speeds, their SI units is meter per second. The SI unit of initial and final speed, meter per second. Then A is for acceleration. A is for acceleration. Units, meter per second square. T for time, seconds as the units. X for distance or displacement, meter as the units. Okay, if you pay careful observation, if you observe the equations on the board, you'll be noticing something, that equations of motion is an example of kinematics. Kinematics. Here we are concerned with motion, distance, acceleration, speed, and time. We don't have concern with what causes the motion. There is no force. The equations of motion does not involve force. Therefore, this is kinematics and not dynamics. Okay, then let's go back to deriving those equations, because that is how best to go with physics equation. You don't cram, you derive, you prove, so that even when you are dreaming, you can prove your formulas with ease. So to do that, observe something. To get these 4 equations on the board, we need just 2 key formulas. Just 2 key formulas. Let's see. We just need the formula for finding acceleration and the formula for finding distance. Those are the 2 key formulas you need. But if you keep your formulas this way, you'll be making a grave mistake. You must involve the initial speed in those 2 formulas. Here we make complete consideration of all parameters in motion. Don't neglect your initial speed. You can see here, acceleration is velocity over time. We've said before now that for a body to accelerate, the speed must be doing what? Changing. Changing speed with respect to time is what we call acceleration. Changing speed with respect to time, acceleration. So this formula is incomplete because it neglected u. So to complete it, we'll be having this is our complete formula. A is equal to V minus U over T. This is what we'll be using. The one that has complete expression of what we need. No parameter is neglected. That is V, that is U. Final speed, initial speed. Here, my initial speed is also neglected. All I have is final speed. I will express it. Distance is equal to get the total distance covered by a body, we have to know the average speed and multiply it with time. Therefore, to get average speed, I'll be doing okay. So the word average is like taking the mean. Here is average speed, but there is change in speed. Acceleration is change in speed over time. Whereas distance is average speed times time. The word change means minus, change. Change, V minus U, change in speed. But under distance, we're saying average speed. That's why we're doing the average or the mean times time. So these are the 2 key formulas that will give us our equations of motion. Okay, let's prove it better. We drop the first one. A is equal to V minus U over T. Acceleration is change in speed over time. Okay, recall the first equation is V is equal to U plus AT. This is the very first equation in equations of motion. Let's see how it was gotten. Okay, from here now, make V the subject of the formula. Make V to stand alone. This over 1. Cross and multiply. Anything times 1 is that thing. V minus U equal to A times T. AT. Our target is to make V to stand alone. Equations of motion. Okay, let's put the 4. So you can know when we've gotten any of the equations of motion. Okay, those are equations of motion. Okay, we'll continue. Let's make V the subject. V is equal to get minus U the other side. Get your minus U the other side. But do not forget that AT is already there. Then when minus U comes there, it becomes plus U. When minus U crosses equal to, equality sign becomes what? Plus U. Therefore, to make a better arrangement, we also have plus here. Before AT is plus, but there's no point indicating it. So let's arrange it to resemble what we have there. Then get U first. It has plus. Don't need to put in it. When plus comes first, ignore the plus, but it's there. Then putting AT here, we now express that plus. Okay, observe. You can now see from equation of acceleration, from the formula for finding acceleration, the one that has complete expression, that has both final and initial speed. From there, we'll get the first equation of motion. So first equation, done and dusted. Okay, then we're proving the first one. You can already see that the second one is exactly what we said. It's just the formula for finding distance, which must have complete expression, both final and initial speed. Formula for finding distance is u plus v over 2 times what? Time. So equation 4, done and dusted. There are 2 equations remaining. Then let's see how to go about them. Okay, at this point we're proving equation 1. And the 2 key formulas for making these proofs are these are the 2 key formulas for getting all equations of motion. Then see what we'll do now. We'll have to do a very smart work here. Here we'll substitute. Okay, let me make t. Okay, but before then, let me go back here. Observe here. Observe. We've gotten v. V is equal to u plus at. We're proving that. So let me go to this equation. Let me call it equation k. Equation k. Let me go to equation k and substitute v. What does that mean? Anywhere I see v in equation k, anywhere I see v, I will substitute with u plus at. Okay, let's see that from the board. Instead of putting v, I'll go and put the other values of v. U plus at over, we'll continue, over 2, we'll continue, times time. Then continue with the expression. Let's see what it turns to become. U plus u, 2u, plus at, all over 2, all multiplied by t. We'll continue with the mathematics. This over 1. T will open the bracket. T will multiply both terms. 2u times t, 2ut. Plus times plus. There is plus outside here. So when plus comes first, it's not indicated. But when minus comes first, it must be indicated. Okay, plus times plus, plus. At times t, at squared, over 2 times 1, 2. Okay, we'll continue. We now have s is equal to 2ut plus at squared all over 2. In mathematics, are you paying attention? In mathematics, if the denominator can divide through the numerators despite the operator in between, if I have common factor that the denominator can divide in the numerator part is allowed. This is what I mean. Or to make it simple, let's spread the denominator. Let's spread the denominator. We have x is equal to, what I mean by spread? Both numerators, irrespective of the operator, share the denominator. We'll be having 2ut over 2 plus, put the operator down, at squared over 2. This is just like going back, because if we want to solve this this fraction, if we want to add these 2 fractions, we're going back to this, finding the LCM, which is 2. Then divide, we bring it back to this way. So both ways are the same. No panic, both ways are the same. But there's a reason for this way, so that we can cancel. Okay, 2 cancels 2. So I'm now left with x is equal to ut plus, there is 1 here, invisible 1. 1 times anything is that thing. Then half at squared. This, the third equation, proving. The third equation, proving. Okay, let's go back to how we started. Just put your formula for finding distance. average speed times time. Then the substitution or the equation that involves v is equal to u plus at. Substitute v in the distance. Substitute v in the distance, where v is equal to u plus at. Then go on with the mathematics. You end up with the third equation. Then the fourth one, do similar thing again. We will see substitute from the same form for finding distance. All substitution will enter here. We've substituted for v. This time from that same equation again, which was gotten from this, we are substituting for t to get the other or the last equation. To get this very last equation, we will substitute for t from these same two equations that are the same but different form. Okay. Still on equation k. See what we do this time. This time we'll leave v. We'll leave v the way it is and substitute t. And to substitute, you have to make t the subject, either from here or from there. So it's easier from here. To make t the subject, there we'll be having t is equal to v minus u over a. Just take t up and get a down. Cross t and a. A goes down, t goes up. Therefore, t becomes v minus u over a. Now we'll now substitute t in that same equation. In the previous time, we substituted v. In this present time, we are substituting t. Then let's go ahead. S is equal to u plus v over 2. Then instead of putting t, we'll put v minus u over a. Then we'll go on with the expression. So to further our equation, S is equal to, in mathematics, this is how to open brackets that involve operators. Just pick your u. Use it to multiply this bracket. Put your operator, pick v again, use v to multiply the bracket. Okay, see what I mean? Get u out. Open the bracket. Put v minus u. Close it. Get your operator out. Plus. Carry v out. V. Put this bracket again. V minus u. I just hope that's clear. Then we'll continue. Over 2 times a, 2a. Then let's go on with the mathematics. U times v, uv. Plus is here. Plus times minus. Minus. U times u. U square. This u. U square. Plus. V times v. V square. Plus times minus. Minus. V times u. VU, but we'll not go for VU. We'll maintain the pattern here. VU and UV are the same. 2 times 3 is the same thing as 3 times 2. But maintain the same pattern. So you can know when you are supposed to cancel the same effects or not. Okay. V times U. VU. But we'll go for UV. Because we already have UV here. All over 2A. Then notice. UV here has plus here. And UV there has minus. They will cancel. I'm now left with S is equal to minus U square plus V square over 2A over 1. Our target is V square. As you can see here, our target is V square. If we must get it in the same form as the equations of motion, we'll make V square the subject. Then cross and multiply. 2a times x, 2ax is equal to minus u square plus v square. I want to make v square the subject of the formula. Then I will push in minus u square the other side. The minus changes to what? Plus 2ax minus u square coming here plus u square equal to v square is remaining v square. Then get v square this way. V square is equal to u square plus 2ax. All 4 equations proven. All 4 equations proven. My dear scholars, in physics, cramming on formulas is not the best way. Deriving your formula is the best way. You can never forget. Recall, in equations of motion, we need two key formulas. Formula for finding acceleration, the formula that has complete expression of that formula, the one that has v and u. A is equal to v minus u over t, change in speed over time. And the second formula is one for finding distance, the one that has complete expression, average distance times time, u plus v over 2 times time. Then keep on manipulating these two formulas, keep on substituting. From A, make v the subject to get one of the equations. Then focus on formula for finding distance, substitute v and substitute t, taking reference from the very first equation, acceleration equal to v minus u all over t. Yeah. If physics is done in this pattern, I bet you will never forget your formulas and you do well in your exams. Please stay tuned. In our next class, we'll be solving on equations of motion. I just want you to get the rudiments of derivation of equations of motion and get prepared for real problem solving under equations of motion. Thank you and do subscribe.